Newcastle University, and hopefully you can see my screen. I've been working with the DAFNI team to try and get one of the OpenClim models, CityCat, onto the platform. And hopefully what this can demonstrate is how you can have not just one model step, but you can have a model step followed by another model step, which uses the previous outputs, as Tom was just mentioning there. So this is my model, my workflow that I've created. You can see it's got, this time, instead of just having one green model step, it's got two. So the first step is run CityCat, so that's going to run the simulation. And then the second step is run impacts. So that's going to use the CityCat results and calculate some flood depths in buildings. And then I've got my visualize step here. So in running CityCat, I've got a couple of parameters. So how much rainfall you want to input, and then the size of the domain that you want to simulate. And then in run impacts, there's no parameters this time, but actually we are including some data from the run CityCat step here. And then in the visualize step, if we're going to load, there we go, you put all your metadata in here. And at the very bottom, we're going to include some data from both the run CityCat step and the run impact step. So that means you get your CityCat model results and also the results of the impact model there as well. So I'm going to show you what that looks like. And these pages are available on GitHub, so maybe we can share the link to these if you want to have a look at what I've done. So the main file here is this is the CityCat model, so the flood model initially. So this is the model definition file. This is where you define a description of what the model does. So CityCat is a tool for modeling, analysis, and visualization of surface water flooding. Great, and then we're defining the input parameters here. So these is the amount of rainfall and the size of the domain. And now I've got the data sets. So the CityCat flood simulation just at the moment uses a digital elevation model. So I've uploaded that into the, there we go, into the data catalog, if we can get to that. So here's my digital elevation model. So I've taken the dataset ID and the version ID, and I put that into my model definition file here. And I specified where I want to be able to read that from. And then don't worry about this. This is just some added information about where the output goes. And then the next most important file is this script here. So this is where I'm then actually doing the work of running the simulation. So I'm getting these input parameters here. So the amount of rain and the size of the DEM, and just creating a place to put the results. And then getting the DEM data from that DEM path that I specified, and then creating the input files, running the simulation, and then zipping up the results. And then this last bit here is creating a metadata file, which in theory means you can use your input parameters to name the output data, but it's something that the DAFNI team are actually working on at the moment, so I don't think that works at the moment. And then finally, you've got your Docker file. Don't worry about this too much. The main thing to look at is just the last line, which says what you're going to do. So you're just going to Python run that run.py file. So that was the model, the CityCat model. And then I've got another model on DAFNI called CityCat DAFNI Impact, which then is going to use the results of this CityCat step. So it looks very similar files here, but if we go into the definition, this time it's called CityCat Impact v2. Assess the impacts using CityCat results, and it's calculating maximum depths. It's using a slightly different data set this time. We're using some master map data from the Ordnance Survey, which I also uploaded here. So similar process, just copy the data set ID across over to here. And then we're going to output one file this time, which is just the building depths. And then if I go into my actual script, which is actually doing the work over here, and then reading the output data from the CityCat model here, so that gets the output data, converts it a little bit, and then reads the building data from that other master map data set over here, and then extracts the depths for each building from the CityCat results, and then saves that to a new file at the output path. And then obviously we've also got a Docker file here as well, which looks very, very similar to the other Docker file, and just a Python run.py. So the outcome of that is then we have some output data. And if we go here, ding, 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 this is the output data that was created by the workflow. And you'll see we have got some output files here. So this is the DEM that was used, the rainfall data, configuration, logs, the zipped up results here. And here's the individual results, and then a max depth. And at the very end, this is the file that was created by the second step, so the impacts model, and this is the building depths. So that was a very quick run through of what I've done so far. At the moment, it's got a very, very limited spatial coverage. So you can see it's just covering Newcastle at the moment because I've only uploaded the data for Newcastle. And we've also got a very limited set of input parameters. So we've just got the rainfall and the size of the area that you want to model, when in reality, there'll be a lot more input data, a lot more parameters, and much wider spatial coverage. So there's a lot more work to do there. And also we can link CityCat to some other models, including the urban development model that Craig is going to be working on. Thanks to the DAFNI team for helping me out while I was doing this. It's very useful. And have you got any questions?